So welcome back, guys. Today we'll be looking at another aspect of motion, and I really want you guys to follow up this series closely because it's been a long time coming already. So you want to follow up and see how these things work because we have been teaching these things step by step. So see you guys as you ride with me on this journey. Today we are looking at analysis of motion. If you recall in our last class, in our previous videos rather, I've talked about types of motion. So today I'll be talking about the analysis of linear motion basically. And I will not be able to do any analysis on motion unless I give you the guiding principles that controls and determine what happens during motion. And one of the guiding principles we want to look at, which is very important, is the laws of motion, or are the laws of motion, and they were propounded by a scientist called Isaac Newton. So I'm trying to keep this simple because we have three laws. First, second, third. They're all important in motion, but I'll keep it very simple. 1 and 2 are the most important in this very thing we are dealing with here. The first law of motion is called law of inertia. And this law states that a body will remain in a state of rest or uniform motion unless it's been acted upon by an external force. Without that happening, I'm standing here. If I don't push myself forward by an internal force, I will not leave this position. The reason why it will not happen is because of that law. I'm obeying that law. I need a force to push me to move forward. So that means there is no motion without force. That's one thing you must just learn. And that's not about the first law. And the second law states clearly that the rate of change in momentum of a body with time is directly proportional to the applied force, and it moves in the direction of that applied force. Or let me say it better this way. The rate of change in momentum of a body is directly proportional to the applied force, or the force you apply to the body, and the body moves in the direction of the net force applied. What does this mean mathematically? It simply means that force F varies directly as change in momentum all over time taken. So we are saying that F equals to change in mv, because momentum is mass times velocity all over time. So if you follow me very closely, F equals to m is same everywhere, like we said yesterday in our last class when we were dealing with measurement. We said mass doesn't change, so mass will remain the same. So mass will not change whether before or after the force has been applied. So we have m outside v minus u all over c. Somebody is asking, how do we have v minus u? Because we have what they call initial and final velocity. So within this space, if you're going to have a change, it's simply saying that you are removing the initial velocity from, sorry, the initial velocity from what? Final velocity, which is v minus u, times what? The m, all over the t. So if you look at this very well, F will be equal to m a. That's where that formula came from, because change in velocity per unit time is equal to acceleration. And that's where we have F equals to what? ma. So put this in your mind as we ride. So now that you understand the first and second law, okay, maybe for the sake of let me actually whet your appetite or help you, because somebody's asking me, what about the third law? What about the third law? The third law simply states that action and reaction are equal and they act in opposite direction. Action and reaction on the body are equal and they act in opposite direction on the body. Let me give you an example. I'm standing here and I'm not falling down because my weight is acting downward and there's a normal reaction on my body upward. If they were not balancing, then I will start sinking. I hope that is clear. And that's the third law. And that's the law that your gun operates by. That's the law that your standing operates by. It's the reason why if you climb on a wet mud that is high, you start sinking until you get balanced. When you get balanced, it means that mud was able to react enough to your weight and bear you. That's why if you stand on a lanky wood and it will get broken and you get injured, because the weight, the lanky wood could not bear your weight, could not give you a normal reaction or balance your weight. So that is that about that. All right, now that you've understood the laws, let's drive ourselves a little further into the next phase called the calculations. Take note that we are just dealing with what? The linear motion right now. There are various kind of motion, like I told you. We are dealing with calculation on the what? Linear motion. So for the linear motion, we are going to be using certain formulas, which we call the equation of motion. This equation of motion were derived based on, from the laws. I'll quickly just run them down for you. So here are the equations of motion, but I would also narrow it down when it comes to my calculation to horizontal motions. And that's the reason why I'm using A. If I was talking about a vertical motion, I'll be talking about G, and there'll be a plus or minus story. But I'll take my time to work out question that deals with the vertical motion in another video. So let's just stay on this for now. All right, guys, I'm having a question right here to solve. And the question says, a car accelerates uniformly at 3 meters per second from rest. Calculate its A, velocity after 10 seconds, B, distance during the 10 seconds. Now, this is pretty simple, but you must understand what to use when it comes to dealing with these questions. Here are the equations you need, and this is how it works. Everywhere you see V in this equation, it's called your final velocity. To help some guys, V is what? Final velocity. Your U is initial velocity. And your S means your distance. Your T, of course, is time. And your A is acceleration. Please note that your S here is distance, your T is time in seconds, your S is distance in meter, your A is acceleration in meter per second squared. Seconds, meter per second, meter per second. Of course, somebody is asking, what's going to have minus? If it's minus, you will not see this flash there. So it's still the same when you see ms minus 1. That's your minus is the slash. So that's that about that. So let's move into solving this very question. So a car accelerates uniformly at 3 meters per second squared. So we have your acceleration is what? 3 meters per second squared. Are we there? Then the question says from rest. From rest means that the body was not moving at all. So that means the initial speed or initial velocity is what? 0 meters per second. Rest. Then say calculate its velocity after 10 seconds. So V is unknown, but you are looking for what? V is unknown, but you are giving time to be what? 10 seconds. So you are asking yourself, which formula combines all of these things here with only one missing and no one excess? That means all these things are available in that formula and there's nothing excess. So let's see. The first, we have A. A is almost everywhere apart from here. So that means this formula will be useless in this question because we don't even have an A. Are we there? Then here, the formula will be useful, just that it contains everything that I need, or except for what? Time. So this time will not be useless in this equation. So this equation is not needed here. Cancelled. Next one, everything is available here except that there's no V on this one. There's no, I don't even need S, so there's no S there, and there's no S there, so I don't need that for that question. Lastly, we have V is available, U available, A available, C available. So out of all of this, only V is missing, and that's what we're even looking for here, and that's the best equation to use for this question. So let's solve with that equation. That V is equals to U plus AT. What is U? 0. What is A? 3. What is T? 10. So we have 0 plus 30, right? We have 30 meter per second because it's velocity. And that's what your A, the A part of that question connotes. Then the B part says, calculate the distance during the 10 seconds. So which formula combines all of these, even with this nearly gotten guy here? There are many formulas with which you can get our answers since they're now working. So I can cancel everything back to start afresh for the second question, which is the B part. Look at this. I have acceleration, I have my initial velocity, and now I have my final velocity, I have my time, and I'm looking for what? My distance. I think this would not really be useful for me. Reason? It might really work like I want, but then I would rather prefer to use maybe, okay, any of this will work. I have this guy. This would not work. Why? There is no distance I'm looking for. This cannot work. Okay, any of these three seems to be able to work. Let's see. Is that really true? Check. I think any of these three would work. Why? There is a U. But I will not use anyone that has a U without my V. I want my V to also what? Show face. So of all of them, the one I really prefer most is this. Or this. Follow me. All would really work if we try them out. Well, let's see if they are going to work, like I said. The B part. Let's say we're using V squared is equal to what? U squared plus what? 2AS. What would our answer be? We have V now to what? 30 squared, right? That's the V we got here. Then we have our U to be what? 0 squared. We have 2 times A is what? 3 times S, right? So all we have here is what? 30 squared, which is what? 900 equals to 0 plus 2 times 3 is what? 6. So we have 6S. I'm writing my S very small, so I don't think it's 5. So we have 900 is equal to 6S. Divide both sides by what? By 6. So we have 6 over 6. So we have 3 here, 2, 3 here, 3, 2 here, 1, 2 here is 150. So we have S is 150 meters. And if you want to try the other means, like I said, you could use this one, this very one. And that's how do you run that? Let's see, if you put your S equals to UT, what's the T? U is 0, T is what? 10. So 0 times 10 is what? 0 is gone. We have half 80 squared, right? What is A? 3. What is T? 10. 10 squared is 100. 100 times 3 is what? 300. Divided by 2, which is the half, 150. So you can use multiple equation to solve a particular question, provided all this is available. I didn't mean I don't have my A now. This formula will now be useless. All these ones will be useless. Only this will be useful if I don't have my A. And let's flow with that too here. Let's see if it's going to work. What's my U? 0. What's my V? 30, right? So is that not true? 0 plus 30. 30. 30 divided by 2, 15. 15 times 10, which is T, 150. So either way, you would get your answer. So I hope this is clear enough. So let's go on to the next question. All right, here's the second question. This looks a bit different from what you're used to. The first one was a story or word problem pattern question. This one is more or less like a graphical question. Of course it is. Then you would want to pick out your values from this. Let me show you how to pick up everything you know. There are four or five parameters you're looking for in every question on linear motion. They include acceleration, right? They include acceleration. They include velocity, that's final, velocity, initial, time, and of course, distance, right? These are all the things you want. So how do you get all of this from here? Sorry, all of this or rather from here. Look at this question. zoom your eyes to this side. It's called the velocity side. And from here to here is the time axis. Velocity axis, time axis. So where is this journey beginning from? This is how you know. You saw the line being drawn from here to here. So it's from here to here. That's the journey. So the journey began from initial time taking was what? Initial acceleration was, initial velocity rather was 4 meter per second. So your U is what? 4 meter per second. My V is the final. So it ended the journey here. So 10 meter per second. Are we following? We are done with initial final. So what was the time lapse between the start point and the end? The time lapse is from 4 to what? 12. If you find a difference, it's going to be what? 8. So it's 12 minus 4, which is what? 8 seconds. Right? Now that you know these three, you have to find what? Distance. Pretty easy, right? I think you can find your distance if you come and check out the formula again. You can get your acceleration if they ask you to even do it. So let's play that. Ask that. I'll do one and I'll ask you to do the other one. The question is, you should find what? The distance covered. Me, I'm saying I'll give you one more after I've solved this, which is I'm looking for this. So which formula will help us get this? If you look at it very well, only one formula can do this. Is it the first, the second, the third, the fourth? Well, for all of you that said it was the fourth, you're right. So the fourth one does the job. So we have that S equals to U plus V over 2 times C, which helps us find out that we have S equal to, what's the U? Our U is what? 4. And our V is what? 10. All over 2 times what? What's our T? Of course, that's 8. So we have 14 over 2 times 8, which is 7 times 8. I think that should be 56 meter. Yep. 56. Is it 56? 7 times 8 is what? Is that so? All right. The answer we got here is 56. And somebody is wondering why we don't have the answer right here. It's because we saw part of it. They said, calculate the distance covered by the body during the motion. So the motion began from this edge. Everybody that is broken is not the entire motion. Can you see that here was broken line was continuous? So we just collected the B part. So what we did so far was the B part from this straight line to this place. So the A part must be what? Gotten and then added together. Of course, you should start from here, though we started from the other end. So if you want to get to the distance here, you have to do the other part. So everything I've done so far here was on the B part. So the A part also has, when I mean A part, I mean the A part of this diagram, which is from here to here, also has its own what? Parameters. It has its U, it has its V, it has its T, it has its S, and even its A. So at that part, what do we really have there? Follow me. We would see that the U here, the journey began here at 4. So it's what? 4 meter per second. Are we following? Again, the journey continued and ended at this point now before it started moving upward. What happens here? What happened here? From here to here was the journey of A. So at this point here, trace it back to the velocity axis, it's still 4. So our V is what? 4 as well. Then our time is what? It's from 0 to 4. So it's 4 minus 0. To give us what? 4 seconds. And our S is what we are looking for. And our A is not given. But let me tell you, it is 0. Every time you have your initial velocity and your final velocity being equal, it means there is no acceleration. In fact, that's the beautiful key to remember. Because a JAMB question can ask you to tell us what you think the acceleration would be if a body accelerates, travels with a uniform speed. Uniform speed means that the initial velocity and the final velocity are equal. That means the acceleration is 0. You don't need to calculate that. You just have to just know it and move ahead. But that means this vehicle was traveling at a uniform speed from this point to this point to make the journey of A. And that means if I want to get my S there, follow me please. The S of B now, S of A rather, I think I'll have to clean up part of this place. So S of A now, I've gotten S of B is equal to the same formula plus V over 2 times time. So we have u is what? 4 plus 4 over 2 times 4. So we have 8 over 2 times 4. That makes us to have 16 meters. So how do you get the total answer? Just sum SA. Total distance is equal to SA plus SB. And your answer is 16 plus 58. Right? 56 rather. And your answer is 72 meters. And that gives you the answer to be C. I believe that is very, very clear. So, guys, we are done so much trying to get examples and solve them. So I hope to see you guys in my next video. Stay tuned to this channel. Don't forget to like, subscribe, and hit the notification bell. See you guys in my next video.